Hello everyone, I'm Xiao Gang. Okay, there's not much to say about this multi-round response. When you send this TLA array, you need to make sure you add this last question at the end. At the same time, you must ensure that the last one ends with a period. For the context, you certainly need to connect the preceding and following parts, right? The front part is your historical dialogue. Recording something like that is relatively simple. The more troublesome part is the streaming, which is also the core content of this chapter. Why did we write so much? It's because I want to explain this streaming to everyone, okay? And then, actually, everything before this is exactly the same. No need to change anything. The most important part is on our remaining HTTP. We need to bind the delegate. I'll point it out to everyone here. There's no problem with the front part, because this required info. It has a field inside. It will identify whether it is streaming its stream. The user just needs to mark it when we send it. If it is streaming, we need to bind a delegate. As for this delegate, actually, if you must use version 5.3 or above, because versions 5.1 and 5.2 do not have this delegate. Without this delegate, you will have to implement streaming in another way. Yes, you will need another method. That is, you have to keep fetching its data and then split it. This is actually not very convenient, okay? We write here. Let's do it here. So if he enables this streaming, then we need to bind this delegate. Then we call this function. Okay, what is this delegate root? This delegate root is actually a delegate root, like this. It's just a delegate proxy. Then let this delegate root bind to our stay_stream method. We don't have this method yet. We'll write it later. Let's first take a look at what this is. You can see, if you are using 5.1 or 5.2, you don't have this method. I was checking at the time. This is the body of the response, and here you need to confirm the cleanup of this data if it fails this situation, and then this HTTP request. Anyway, if it fails, it will exit or something, and you need to pay attention. That is, once you use this method, once you use this method, it is its calling timing. Once you use this method, when you call this method, it will be empty. That is, once you have this thing, then in this place will actually become. That's what it means. So when we are doing the loss, at the very end, this place needs some special handling. So now you understand that the proxy works like this. And actually there are some other proxies. You can see here. See if you can jump into this. You can observe its progress here, or some completed states, or some engaged states can all be implemented through these bound delegates. You can take a look at this yourself, how we will proceed next. We need to implement this method, the function signature of this method. What is it? Then you can see its signature is actually in this. That's it. Its signature is a wall new, a boolean, and an int6 for length. So this means it will be called when this HTTP request is sent and received. When using the streaming method to handle data, this delegate will be activated. So here, we need to write this delegate. We write it into this. Write it below. It's called the HTTP stream delegate. Okay, now let's implement it. Okay, this delegate is used to handle each time we stream and receive this data. First of all, we must return this tool, because once we return false, it directly kills this request. And then here we go to prepare a piece of data. This temporary data we append it to this. Append it to this. Okay, alright. And then at this point, we need to process this data. Then we first get our own pointer. And if this pointer exists, this pointer must exist. If it exists, we need to issue a task for part 1 to call it to the main thread for execution. Because here it might not be clear here which thread it came from. Anyway, for this data, we let the main thread handle it, because we need to do the callback on the main thread. Okay, wait, let me set a breakpoint. then we'll know which thread it came from. Here, let's capture this data. Okay, now we've reached the main thread layer. Okay, actually, I was a bit cautious when writing this part, because I'm not entirely sure, because this involves crossing layers. I'm a bit worried that this object will be destroyed, but actually this object won't be destroyed because you know our object. As long as it doesn't fall into a method like resource, it won't be destroyed. So it should be relatively safe. Then we need to prepare another method to handle the data that is passed to us. We'll write this method later. We'll process this data in the main layer. Okay, so now coming to the main layer, how do we process this data? What is sent over here is actually binary data. Today, we need to transcode and append. First, we check whether the engine has exited. If the engine has already exited, we will ignore our data. Then here we do a transcode, which means we convert this data from UTF-8 to TTAR. Then we forward it to our F stream after the forwarding is complete. Then next, let's take a look here. Here, we should create a write string. We create a write stream. We need to read this data inside here. Okay, then if finish reading this data, it has been serialized successfully. It should have used this. Okay. If it has been deperialized successfully, then we need to check, because if it fails, this data displays well. Why do we need to do this? It's because it might fail. When it fails, you need to determine this thing, whether it has this error code. If it has this error code, it means it has failed. So here we pass this data to our, that is our chain failure. It's where the failure occurs. Okay, let's switch to this view. Let's handle this failure first. We put this data here. Okay, this part is not written very elegantly. No time to optimize. Okay, this place should be, even if we take all of these and put them here. Okay, it should be this one. We haven't used this one yet. Let's put this one here too. So if we, in this place, if it fails, then it will only give a failure data. There won't be any retained data. So for the failure data, you can get this error code right from the start. If you get it here, we just return directly here. Okay, we'll process it at the very end. Process it at the very end. So we fail here. There is such an erroneous piece of data. If it succeeds, we add this piece of data to our drain dataset. Just add it here. This part is mainly for handling the case where a failure occurs, and at this point, our data is continuously being written into the mainline layer. Then every time we write a piece of data, we need to perform a recursive processing of this drain data, because with this data, you are not quite sure what the actual progress of the transmission is. So we need to write a method to recursively handle the lost data. Okay, since this part is already on our main thread layer, the data we need to capture is all on the main thread layer. We can just process it directly here. Okay, so first of all, we will make a simple judgment here. This part is written quite specially. Let me show it to you first. That is, how do we determine, is it a whole segment of data? First, let's find an index. Because it's all U8, let's create a for loop. Then, once we determine that this condition is met, we consider that there is now a segment of data. We can take this preceding segment of data and extract it. So what does this mean? Mainly, look at this. Because here there is a, you see, between each segment of data, there is a line break, right? After you receive this data, there is a line break. So actually you might, so when you receive this, then it won't work. And when you receive this, it also won't work. You can only receive this piece of data. That's it, this piece of data. After receiving this piece of data, adding two new line symbols, then so we consider this piece of data can be extracted. So this is okay. You should understand what I mean. Yes, that is, we will keep iterating through this array. It goes on and on like this. After a certain segment, we cut it out. So how do we determine such a condition? We need to traverse it once. So we use dex. We start from the beginning as long as it has 2 consecutive characters, both equal to 10. That is, its code equals 10. This code does not refer to its value, but its order equals 10. Then as long as it has 2 consecutive units of this order, and this value equals 10, you need to understand that this 10 does not refer to 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. It is within our ASCII code. When it equals 10, then it should actually be this thing. It is this thing actually. When it has 2 consecutive things equal to this, it should mean this. Then once there are 2 consecutive equals to the, we consider that the position here is the position we want to cut. For example, if it transmitted this much data, then it traverses to this position, traverses to this. For example, 20, when it traverses to this position, then it considers the previous segment, so it can be cut out now. Next, we need to proceed with, let's record this index, then let's start cutting. If we keep iterating and never find it, then we'll just ignore it, okay? But if we do find it, and we find the index of this first segment of data, then we'll start cutting this data. So how do we cut the root? First, we prepare a segment of data, then we take this hand part, the data from the front part, and extract it only after it comes out. Then we take this old data and remove it. Because we have already taken this segment and extracted it for processing, then here we need to encode this character string and perform a transcoding because we haven't transcoded it. Earlier here we only extracted the error information and didn't modify it after extraction, so only after transcoding here. Then we go and do this. Let's save and process it. We can see here we need to take this element data. This is the original save, So, and then this is also the original, this part. This original is mainly for you to see what it outputs because it comes with data. We don't want this data when saving, right? So we need to remove this data. And how do we remove this? Here we directly use remove from start. This way we can remove this data. So this is the actual node we need to process. This is the original node. There's a data in front of it that we don't need. Then we can print this log for this log to make it easier for everyone to see. We can set the log level higher to display. Of course, when you use it yourself, you'll need to delete it yourself. We won't worry about that. Okay, then let's check again. If here this thing contains this shoe changing var, it means there is a problem. Because what we want is to delete this thing. So we should not have this thing. So there is an error in the flow here. We might need to change the way the flow is written. Okay, so because this flow is between the server and the client, they need to agree on the protocol for this flow transmission. So this is how we judge it here. Then after processing it like this, we can get this piece of JSON. Then we just need to return this piece of JSON. That is this piece of JSON. So how do we return it? Then let's prepare a string medial message. We don't have this medial message yet, right? So we need to write this medial message. Okay. We find our race type. It should have a medial message. Let's put it at the bottom. There's a bit too much stuff written here. Let's finish writing it once it's written. Actually, it has a medial message, its own fellow message. So let's copy the part before this. Okay, we don't have these 2 structs yet. Let's define these 2 structs earlier. Let's put them at the very beginning. Let's find this struct. I'll copy it over. Okay, let's put it below. Let's put it in this data. Let's put it in this position. I'll just copy it over directly here. Just copy it over directly. It's a bit long. What information do these fields correspond to here? Similarly, it also has this search info. We'll take this one. We don't need it. Let's collapse it. It's header info. Let's see what it has. It has a search info and usage. So we defined it earlier. So let's collapse this part. It should be this one. This should be it. You see right here? And we need to align this name as well. Let's collapse this first. Okay, we have a lot of things to align here. This part. Okay, let's align this over. You can directly copy mine here. That's totally fine with me because this thing isn't technically challenging. And there's a search info earlier. It should be placed here. Alright, it's done. So this corresponds to that. Well, we can see these fields for the flow response. That's all there is. Just these fields. Let's see if it has a response table. Actually, this e par the d tar t. Yes, the specific flow response. It responds to these fields, and everyone can see at a glance that it matches. Okay. Good. So this flow response, that's roughly it. And then this final piece of information, what does it look like? This final piece of information is actually defined by us. Because this information, we actually need to retrieve this header information and this total string. So this part is defined by us. Let's paste it over, okay? Then let's also call this header over. Okay. Here, I recommend you don't write it yourself. Just call it. Okay, let's look here. There should be no problem. There should be no problem. Good, let's go back to our action here. Now we need to handle it recursively. Right, so here, let's change the name. The name should be here. It should be this one. Media data. It should be this one. Good, because we need to deserialize it. Before we process it, we need to let it build first, because we've already written quite a bit of code. I'm worried this issue might come up. So what's done here? Once that's done, we'll come back to this place. Continue writing our recursion. This part needs to be recursive because you might have many segments of data. So you let it recurse. That is, it must handle each pass cleanly. Then here we take our processed result and give it back to virtualization. And this is essentially an update of information. Here we put this respite info here. Okay, this update information is successful. It is elapsed, and its result is this medium message. The result inside it, corresponding to this, it is this result. No problem. And here there is a JSON. This is the original JSON, and this is the intermediate or just elapsed struct. Right. You see, it is that. Okay, after processing is done, then we add this total string. Because we need to accumulate. Some people might need to verify one more time at the end, or something like that. Then at that point, we do another update. We trigger our update pin. Then the update pin will be triggered. And okay. Then finally, we do a recursion. Because there might be multiple segments of data, we only processed one segment here. So we keep processing until there is none left. Then it stops, and then it waits until the next time something comes in. Right. Something comes in again. All of this is done on the main thread. We can set a breakpoint and wait. So basically we have finished writing it. So after finishing the new style writing here, there is still one place we haven't finished writing. Let's finish it all at once. It should be here. We still have one last piece of data. We need to process this last piece of data here. Okay, so let's stop here for this lesson.